In the last video, we mentioned that the periodic law says that groups of elements form with similar properties when you organize the elements by increasing atomic number. That's exactly what we're going to look at in this video. Some groups in the periodic table and some of their distinct properties. Group 1. These metals are called the alkali metals. This is your lithium, sodium, potassium, rubidium. Let's make a little note. Group 1, not including hydrogen. Hydrogen is not technically an alkali metal. Hydrogen is a non-metal, and we'll deal with them in a little bit. The alkali metals really start with lithium, sodium, potassium, rubidium, cesium, and francium. We're going to look at some of the alkali metals in class. They have some kind of crazy properties. They are metallic. They do have luster. However, they are highly, highly reactive. These are the most reactive metals. So, I mean, in general, they do have all the properties of a metal. There are melting points and boiling points, and they're lustrous, and they're conductive, and all that good stuff. Here, we'll just maybe put down some of their more unique properties. They are highly reactive, the most reactive. They're so reactive that when I show you these elements in class, most of them are stored in oil. They'll react with water vapor in the air. They'll react very violently if we put them in water, which eventually is what we're going to do to prove that they're highly reactive. But they are often stored in oil. Now, again, they're so reactive that the outside often dulls really fast. It reacts with oxygen in the air. So it gets like this sodium oxide coating. But if you scrape that off, the sodium metal on the inside is very shiny and lustrous. We could put that down. They react with water. They'll react with gases in the air. Which again is why they're often stored in some kind of a mineral oil or a non-reactive oil. They're very soft. It's kind of a unique property. You can cut these metals with a dull knife, which is what we'll do. I'll show you some of these guys in class. So in order to kind of get rid of this oxide coating on the outside, maybe you can kind of see it on this potassium. You just take a knife and you can slice into these metals. That's kind of unique. You can't slice through a piece of copper with a dull knife. But these guys you can. Now, one of the other things that we're going to look at is this term valence electrons. Valence electrons, let's get this down. These are the electrons. In the outermost energy level, outermost shell. I think we briefly mentioned this term when we were talking about electron structure and electron configurations. The inner electrons are the core electrons. Those really aren't all that important when it comes to chemical reactions and bonding. It's the outermost electrons. Those are the ones that are going to interact with neighboring atoms. The valence electrons are very important. Now, for example, let's do a couple of these electron configurations. Lithium. Lithium. If I do the noble gas shortcut, lithium would go back to helium. And then all I need is 2s1. Sodium. Let's say I do sodium's electron configuration. With the shortcut, Sodium is number 11. We'd go back to neon. And then I'd have 3s1. Next, let's do potassium. Potassium is number 19, so I'd go argon. And then this would be 4s1. Do you notice a trend? You do. I see that you do. All of these will have one electron in the highest energy level. We call that the valence electron. Number of valence electrons, 1. They all have one valence electron. One electron in the highest or outermost energy level. Now again, here we can see it real easily if I do the noble gas shortcut. We said the noble gas shortcut is kind of nice because then you're usually only focusing on the valence electrons. Now if I were to do this the long way, let's say I have sodium. The long way, we'd say 1s2, 2s2, 2p6, 3s1. These first 10 electrons, these guys are called the core electrons. They really shorten up and they can be simplified as neon. The first 10 electrons will have the configuration of neon. The core electrons are all full orbitals that are very stable and they're not involved in bonding. This is the most important electron, the highest energy level. The valence electron. The highest energy level is the third. It's got one electron in the s orbital. All of the elements in group 1, all alkali metals, will have one electron in their highest s orbital. They will all have one valence electron. It's the electrons that are involved in bonding and chemical reactions. So since they all have a very similar electron structure, one electron in the highest s orbital, they'll all react very similar. They'll form similar bonds and they'll do similar things in chemical reactions. Let's hop across to group 2. Group 2, the alkaline earth metals. The alkaline earth metals are still very reactive. And obviously they are all metals. And again, we'll look at some of these in class. They are lustrous, they can be malleable and ductile, they're good conductors, etc. But they are very reactive. Some of them still do react with water. We'll do that in the lab. We'll put some calcium in water, and it does react somewhat violently. Now, maybe not quite as violently as group 1. You may have heard that things like sodium will often burst into flames when you put it in water. They're highly reactive. Magnesium, calcium, strontium, barium, they may react with water, but not quite as violently. Now again, they all have very similar properties because their electron structure will be very similar. Let's look at a few. Electron configurations. Beryllium. Let's do the noble gas shortcut again. Beryllium is element 4, so I could shorten it up and say helium 2s2. Magnesium, element 12. I could put the first 10 electrons in as neon 3s2. Calcium is number 20. So I can go argon, that saves me 18 electrons. Oopsie, 4s2. Argon 4s2. And again, you're probably seeing a very similar pattern. They'll all end with 2 electrons in their highest s orbital. Because their electron structure is similar, they have similar chemical properties. The number of valence electrons is 2. They will all have 2 electrons in their highest energy level. They'll happen to all come from the s orbital. So group 1 and group 2, highly reactive metals. Group 1 is even more reactive. These group 1 metals are crazy, which is why, again, they're often stored in a non-reactive material because they'll react with water, they'll react with any gases in the air. These guys not quite so extreme. Their electron structures are what give them the similar properties. Everybody in group 1 has 1 electron in their highest energy level. Group 2, they all have 2 electrons in their highest energy level.